What happens if a million people hit this at the same second? That was the question sitting in my head while I stared at my one server running on my laptop, handling one request at a time. Request in, response out, clean, simple, the only model I'd ever known. I drew it out, one box, one arrow in, one arrow out, then added a second user, then 10, then 1,000, and the diagram didn't break, it just filled up with arrows all pointing at the same box, and that's when it got uncomfortable. A box can only do one thing at a time. So what happens to arrow number 2 while the box is still busy with arrow number 1? It waits. And waiting doesn't sound dangerous until you ask how long a line can get before people stop waiting in it. I couldn't simulate a million users, but I could fake enough load to see it happen. So I wrote a small script to fire repeated requests at my own server, faster than I could click. 10 requests, instant. 100, still fine, just a flicker of delay. I kept raising the number, watching the terminal. The responses stopped arriving instantly. They started stacking up, not failing, just queuing, piling behind each other like cars behind a red light I couldn't see. So I thought, buy a bigger server, more power, more traffic, solved. So I pushed the idea further, tried to imagine a server powerful enough to never queue, and the more I imagined it, the more it fell apart. Because no matter how big that machine gets, it's still just one thing doing one thing at a time, which means I hadn't fixed the wait. I just made the line move slightly faster before it formed again. So what if it wasn't one machine at all? What if it was 100 smaller ones, splitting the work between them? That felt right until I hit the next problem. If there are 100 servers, who decides which one gets which request? Somebody has to stand in front of all of them and choose, request by request, in real time. And that somebody can't be a person. It has to be another machine, doing nothing but watching, deciding, sending. I sat with that for a second, then pulled at it harder. What happens if one of those 100 servers just dies, mid-request? Does the whole thing go down with it? I expected yes. The answer was no. Whatever was standing in front just stops sending it anything and shifts everything to the ones still alive. And somewhere out there, a user sends a request, gets a response, and has no idea a machine just died to make that happen. The internet I use every day isn't one impossibly powerful computer. It's thousands of ordinary machines, none of them special alone, arranged well enough to behave like a single one. That answered the question I started with. But it left a quieter one behind. All those servers, spread out, surviving crashes, sharing the load, they're still not working in isolation. At some point, almost all of them need to read or write the same data, the same accounts, the same messages, the same photos, which means somewhere behind all of them, there's probably one thing they all depend on, a database. And if that's true, I already know what I'm asking next. If 100 servers can share the load but they're all still talking to one database, have I actually solved the bottleneck? Or just moved it somewhere I haven't looked yet?